Today's lesson is going to be on adding and subtracting radical expressions, 2E. Mine is going to start on page 220. For adding and subtracting radicals, we need to do three things. We first need to start by simplifying all radicals that exist in the problem. After that, we are going to identify the radicals with the same index, remember square root, cube root, or fourth root, and the same radicand, so that's the number under the radical. Only these can be combined. For common radicals, you want to add and subtract the coefficients and keep the common radical. So we're going to take a look at a couple of examples. The first one being 3 times the square root of 27 minus 2 times the square root of 12. When we look at this example, we can notice that we're looking at square roots, but square root of 27 and the square root of 12 are not simplified. So step one says we want to simplify these. So we are going to break down 27 into 9 times 3, and we know that 9 is 3 times 3. So we have this pair of 3's. So we're going to bring out the 3, and under the radical we are left with a 3. But there already existed a 3 out in front, so we have to multiply that. So really we have 9 square root of 3. Then we are going to come over here to the square root of 12, and that is 4 times 3, and 4 is 2 times 2, so there's our pair. We're going to bring out the 2, and we're left with radical 3. There already existed a 2, so remember we need to multiply by that, and the subtraction sign comes down. So we have 4 square root of 3. So the next thing is that we want to identify the radicals with the same index. This is the square root and this is the square root, and the same radicand. They both are the square root of 3. So now, because we have a common radical, we are going to add or subtract the coefficients. The coefficient here is 9 and this is 4. And we have a subtraction problem. So really what we have is 9 minus 4, which is 5, and then the radical stays the same. So our simplified version is 5 square root of 3. Our second example is going to involve cube roots. So we are looking at 3 times the cube root of 54 minus 2 times the cube root of 2. And then I'm going to go ahead and throw in another one, plus 7 times the cube root of negative 16. So we're going to simplify this, but this time around, instead of looking for perfect squares, we're now looking for cubes. So I'm going to break down 54, and if I don't remember my factors, I can always use my calculator. And I know 54 is 3 times 18, and 18 is 3 times 6, and 6 is 3 times 2. So here's my 3 3's that I need. So bring that out in front of my radical, which is a cube root, and the 2 stays under. The 3 that was already outside comes down. So we have 9 times the cube root of 2. This next one, I can't simplify any further. So if it's already in simplest form, we bring it down and we don't need to simplify it. Sometimes we get those nice problems. The next one, we want to see what we can simplify in terms of cube root of negative 16. Well, I know that 16 is divisible by 4, but that's a perfect square. So instead of dividing by 4, I'm going to divide by the negative 2. And so I get 8. And 8 is actually going to be negative 2 times negative 4, because I need that negative 2. And negative 4 is negative 2 times a positive 2. So here's my 3 negative 2's that I'm looking for. And so what comes on the outside is that negative 2, and the positive 2 stays in. But remember that I had a 7 out there, and it's not 7 minus 2, it's 7 times negative 2. And so that gave me a negative 14 times the cube root of 2, and I had a plus sign, so that plus sign needs to come down in front of here. If I want to change it so that it's minus, I can. So right now I'm looking for the same index, they're all cube roots, and my radicals just so happen to all be the same. So what I'm doing is I am subtracting here, so that's going to give me 7 cube root of 2. And then plus a negative is really like minus 14 cube root of 2. And so I simplify that one more time. 7 minus 14 is negative 7 cube root of 2 is my final solution. So as you can see from my two examples, I can have 2 or I could have 3. Some are going to need to be simplified and some are actually going to already be simplified for me. Now these were just using numerical values. The last example we're going to take a look at today is where we incorporate a variable. The same process happens in the variables as it does with the numeric examples. So this time around, we are going to take a look at the square root of 98 x to the 4th y squared minus 3x squared y times the square root of 2. So when I see a problem like this, I'm hoping that what I'm going to be left with on this side is just a square root of 2. Otherwise, I'm simplifying and not being able to add or subtract. So I know since it is divisible, it ends in 8, it's divisible by 2, so it's really 49 times 2, and 49 is 7 times 7, so here's my perfect square that I need to pull onto the outside of my square root, and then I'll be left with that. X to the 4th is really x squared times x squared, and then we have the y squared. So here's my group of perfect squares. And because I have a y squared, actually I can bring out a single y because the square root of a square is singular, and we have the square root of 2. And then all of this comes down, minus 3x squared y square root of 2. So again, I'm not subtracting the coefficient in terms of variables, I'm subtracting the numerical coefficient. So 7 minus 3 is 4, the x squared y stays, and then we have the square root of 2. We're going to take a look at some more examples in class where we work on simplifying the adding and subtracting.